Alright, so in this lesson you're going to look at trig in a slightly different way than what you've been used to looking at back in grade 10 or potentially in 3M if you took that course as well. So up until now, all the trig you've been doing has been done with inside triangles to try and solve for different sides and different angles. That's not really necessarily the case with most trigonometry questions you're going to run into outside of school or in engineering or any kind of program you go into. You're looking at angles in other situations, like mainly angles on the Cartesian plane. So the actual definition of an angle is that it's a ray rotated about a fixed point where the fixed point is called the vertex. So essentially, if you have two different lines, so we call the initial arm and the terminal arm, the angle is what you get from rotating from the initial arm over to the terminal arm. So here, we start over here at this green line here, we end at this red line here, and we rotate for this first angle here counterclockwise from the initial arm to the terminal arm. In theory, you could also rotate the other way and go all the way around here to get another possible angle. Again, away from rotating from an initial arm or initial starting point into a final point. Okay, now, this is a weird way of looking at angles, a way you're not used to looking at angles, but in general, we're going to work at angles in what we call standard position. They're a little bit easier to work with, a little bit easier to visualize. So in standard position, we're going to have angles drawn in the Cartesian plane where this vertex, where the initial and terminal arm intersect here, is going to be at the origin, and the initial arm is going to be in the positive x-axis. So in general, most of your angles in the Cartesian plane are going to look something like this. So we're going to have an angle going from the positive x-axis, rotating out to some final, what we call terminal arm. So just in terms of getting these definitions down cold here, this right here is going to be your initial arm. Okay, this right here is going to be what we call the terminal arm, or where the angle ends. Okay, and again, the angle is what you get from rotating from the initial arm to the terminal arm. Okay, so you got a few examples here where we, again, start rotating from the positive x-axis and end at some terminal arm. And one down here where we also go from the positive x-axis to the terminal arm, but we rotate the other direction. So the slight difference between these cases here is if we're rotating counterclockwise, the way we see in these first two examples, we call it a positive angle. Okay, so the angle is going to be greater than 0. If we rotate the other direction, so clockwise like we do here, we're actually going to have a negative angle. So you haven't really dealt with negative angles before, but what they actually do mean is just rotation going clockwise around the Cartesian plane towards from your initial arm over to your terminal arm. Okay, so again, counterclockwise rotation will be positive, and clockwise rotation will be negative. Okay, you're going to see a whole lot of definitions today that are going to take a little bit of getting used to, but they do show up a lot, not only in this course but in 4U as well. So they are worth getting to know. So just to recap here, Cartesian plane, we do have 4 quadrants in them, quadrants 1, 2, 3, and 4. If we were to have an angle here, so again, if we were to start rotating from the positive x-axis here, we could rotate, rotate, rotate. Well, once we hit right here, we've now reached a 90 degrees worth of rotation. So if you have an angle that stops anywhere in quadrant 1, it's going to be between 0 and 90 degrees. Okay, if we continue this rotation, keep it going, okay, we're going from 90 degrees until down here, which becomes 180 degrees. So in quadrant 2, your angle will be measured between 90 and 180. Okay, you can keep going. The next quadrant will be your angles between 180 degrees and 270 degrees. And your last quadrant will be between 270 and 360 degrees. So if we're rotating in a positive direction, one full rotation will be 360 degrees around, which is how you're used to seeing degrees, right? You know, in a circle is 360 degrees. Same idea here. You rotate one full rotation around the Cartesian plane, get 360 degrees. Okay. And again, this is assuming positive rotation, and depending where your terminal arm lies. So, for example, if you were to have a terminal arm in quadrant 3, if you were to rotate all the way over there, your angle would be somewhere between 180 degrees and 270 degrees. Okay, so another definition here, what we call coterminal angles. Angles are coterminal if they share a terminal arm when they're drawn in standard position. So what does that mean if they share a terminal arm? Let's take a look at Cartesian plane here. And let's just say I have an angle, terminal arm, in quadrant 2. So I could have an angle right here that starts again at the positive x-axis, ends there. that's not the only angle I could draw that starts at the positive x-axis and ends here. Okay, I could have one going, again, from the positive x-axis, doing a full rotation around, and then coming back and stopping there. So this is another possible angle, so I'll call it theta 2, that starts at the positive x-axis and ends at the same spot as my original angle does. And that's not even the only one from there. I could do an one where I go rotating around two full rotations before I end there, 3 full rotations, 4 full rotations, and so on and so forth. I could even have ones where I start here and go in a negative rotation and end there. So because all these angles share the same terminal arm and they all start from the same spot, they are called coterminal. And how do you get them? Well, let's say I'm going from theta 1 here, this initial one, over to theta 2. Well, the only difference is this second angle here has gone through an extra full rotation of 360 degrees. Okay, so, and if I'm looking at even at the negative one, going from here to here, I'm just going backwards 1 full rotation. So I can always find new or coterminal angles to the one I have by adding or subtracting multiples of 360 degrees. So let's just, again, to try and put this into perspective here, let's look at an example with actual numbers in it, okay, just so it makes a little bit more sense. If I'm drawing in my Cartesian plane, and let's say I have an angle of 45 degrees. Okay, so let's say I want one that's coterminal, one that does a full rotation and comes back. How many degrees has this been rotated? So it goes 360 degrees for a full rotation plus the 45. So this angle in blue here is going to be the 45 degrees plus 360. Okay, so this one's going to be coterminal again because it ends at the same spot as my 45 degree angle. Okay, if I want one going the other direction, well, how much is this really rotated? So it's gone negative 90, negative 180, negative 270, and another 45 degrees here to get to negative 315. The other way I could get that is by taking my 45 degrees here and subtracting 360. So again, all of these angles are coterminal to the 45 degree one I've already drawn. Okay, and just when you weren't finished with definitions, we got another one for you. So when we talk about a principal angle, so looking at what we drew over here, we have a whole bunch of angles that are considered coterminal. The one that's principal is the one that is between 0 and 360 degrees. So it's going to be positive rotation and less than 1 full rotation around the circle. So it'll be between 0 and 360 degrees. And we're going to be wanting to work with principal angles as much as possible because positive angles are easier to work with than negative angles, and you don't want to make angles unnecessarily complicated. So if there's more than 1 full rotation, well, why not deal with one that ends at the same spot that's smaller to work with? So to look at how to find a principal angle, let's just say we have this one down here. So you can see this one, we're rotating clockwise, it's negative rotation. So it's not going to be between 0 and 360. If we add 360 to it, what we're actually going to get is this red one right here. So again, compared to what we had there before, it starts and ends at the same spot, but now it is positive rotation. So it's rotating counterclockwise, it'll be positive, and it'll be between 0 and 360 because it's not doing a full rotation. So this would be the principal angle, but it's coterminal to the blue one that was drawn in there before. Okay, and last but not least, in terms of your definitions for today, we're looking at what we call the related acute angle. So once we have a principal angle drawn, the related acute angle, which we're always going to use a symbol, Greek letter alpha, to indicate, is going to be the acute angle that's made with the closest x-axis by the principal angle. So again, closest x-axis, not y-axis. Always has to be the x-axis. So here in this angle drawn here, well, there's my terminal arm. What's the closest x-axis to the terminal arm? Well, it's going to be this one down here. So this right here is going to be your alpha. Okay, over here in the second diagram, nearest x-axis is there. That's going to be related acute angle. In this one, nearest x-axis is there. And in this one, there you get your nearest x-axis. And you can sort of see from the graph here that there's going to be a relationship depending on what quadrant you're in between the alpha and the theta that's there. So in this situation here, where the terminal arm's in quadrant 2, we have theta being 180 degrees minus the alpha. So 180 degrees gets you all the way down here. Subtract the alpha, you get the actual blue angle there, theta. Over here, theta and alpha are one and the same. They're both in the same quadrant. Okay, down here, if you want to get theta, it'll be 180 degrees plus the alpha. And the one over here in quadrant 4, it'll be 360 degrees minus alpha to get your theta. Okay, and it always helps to have these drawn out. It's easier to see these relationships when it's visual. Sometimes it's hard to picture them in your mind. So in general here, let's try to look at some examples here. So let's look at 135, 217, and 65 and try and find the related acute angle for each of these. So I strongly suggest, like I just mentioned, that you sketch all of these. It makes it easier to see the relationship. So if I draw 135 degrees, first thing you got to ask yourself is, well, what quadrant is that in? So 135 degrees is more than 90, but it's less than 180, so it's going to be somewhere in quadrant 2. So that's going to be 135 degrees. Okay, my related acute angle, again, is made with the nearest x-axis. So it's going to be my alpha there. So how can I find that? Well, it's 180 degrees to get all the way over here, so all the way to the negative x-axis. And then, so if I go 180 degrees minus alpha, I get 135. Or I can go 180 degrees minus 135 to solve for my green angle right there, the alpha. So alpha will be 180 degrees minus 135. So that should give us 45 degrees. Okay, I'd like you to try and do this on your own for parts B and C. So again, sketch the angle, see what quadrant it's in, and see if you can use that to figure out where your related acute angle is and what the measure of that angle is going to be. Okay, so try that on your own again and push play and you're ready to see the answers. Alright, so take a quick minute there to check your answers. So just to recap how I got them, I sketched 217 degrees. That's going to be in quadrant 3 because it's between 180 and 270. So once I have it there, my alpha is made with the nearest x-axis, so it's right there. Now, to find that, if I go look at my entire angle, 217 degrees, and subtract 180 degrees from that, so that would be this amount right here, all that's left is going to be my alpha. So I go 217 minus 180 gives me 37 degrees. Okay, for the last one, 65 degrees is in quadrant 1. So if I'm in quadrant 1, I have a blue angle there being 65 degrees. Alpha is made with the nearest x-axis, so it actually happens to be the exact same as the 65 degrees, so alpha is just 65 degrees in this case. Okay, a couple more examples to go here. So with each of these examples, I want you to find the principal angle, find the related acute angle, then find some other coterminal angles. So if you look at this one right here, 3,745 degrees is far larger than 360 degrees. And if we want a principal angle, remember that it has to be between 0 and 360 degrees. Okay, so to find one that is, find a principal angle, this is far too large. Basically, this has been over-rotated, right? If you picture each rotation as being 360 degrees, to get up this high, you'll have to do one rotation, then another rotation, then another rotation, and so on and so forth. It's going to get very, very messy very, very quick. So we don't want to deal with that. What I want to do is find the principal angle. So since this has been rotated too much, what you want to do is subtract rotation of 360 degrees. And you want to keep going until you get something that is between 0 and 360. This might seem like a very tedious exercise here, but you can also just, if you see that this is far, far too big, you can subtract multiple instances of 360 at once. So you try subtracting, 8 360s, 9 360s, 10 360s, and again, just keep going until you get down to something between 0 and 360. So if you keep going and do that, you're going to eventually wind up with a principal angle of 145 degrees. So this is going to be a principal angle, again, because it's between 0 and 360 degrees. Okay, once I have that 145 degrees, I can start answering the rest. So for part 2, it wants me to find the related acute angle. So 145 is in quadrant 2. Okay, so I'll make this my alpha. Alpha will be 180 degrees minus 145 degrees, which is 35 degrees.